This is the second page of the Algebra 2 Lesson 1-4 notes over solving absolute value equations. In our first example, we see that it is not an equation. We are simply expected to substitute 4 for x and work this problem out based on the order of operations, but paying special attention to the absolute value. Please remember to keep your absolute value symbols in your problem until you're ready to take the absolute value of a certain number. For instance, in this case, 6 minus 8 is negative 2. In my next step, I will take the absolute value of negative 2. The absolute value of negative 2 is 2. And I finish up the problem with 2.7 plus 2, which would be 4.7. The remainder of the problems, the examples in our notes, ask us to solve and check solutions. In each of these problems, we notice an equal sign. Therefore, they're equations. There's a certain procedure for solving absolute value equations, and that begins by writing two equations. The first equation is exactly as it is. However, the absolute value symbols are dropped. Y plus 3 equals 8. The second equation would again have absolute value symbols dropped, but would be y plus 3 equals negative 8. Change that value on the right side of your equal sign to the opposite, and go through the normal steps for solving. In this case, y is 5. In this case, y is negative 11. Now, these are our two solutions. However, we must check our solutions. If we don't check, we may find that we really do not have two solutions. In other words, with these absolute value equations, you could have two solutions. You could have one solution, or you could have no solution. So to do the check, you must substitute into the original problem, or in other words, the original equation. And I usually remind my students to substitute into what was printed as the original problem, what was printed in the book, or what's printed on your worksheet. In this case, that's substituting into the absolute value of y plus 3 equals 8. We end up with the absolute value of 8 equals 8, which is true. So that implies that this solution of y equals 5 is one of the solutions. Now let's check the other solution. Again, substituting into the original problem. And the absolute value of negative 8 also equals 8. So that proves our answer is also negative 11. Since we have two answers, technically we would write this solution out as a solution set, which, remember, a set of numbers is inside braces. The numbers are separated with a comma. Order is not important. It does not matter which number you list first, but they, again, are inside a set of braces. The solutions are 5 and negative 11 here. Moving on. In our second problem like this, which is actually example number 3 in the notes, we notice there's something else on the left side of that equal sign that really should not be there. I'm implying the plus 5. That plus 5 should not be there. We cannot write our two equations like we did on number 2 with that plus 5 sitting right there. So, to get rid of that plus 5, we simply must subtract 5 from both sides. That would leave us with the absolute value of 6 minus 4t equals negative 5. But this causes a problem. This causes a problem because we can't take the absolute value of something and have it equal a negative. It will never happen. You can't take the absolute value of something, no matter what it is, and have it equal a negative. So that implies that this is no solution. The interesting thing here is that if I didn't recognize this, I could write out my two problems. 6 minus 4t equals negative 5, and 6 minus 4t equals positive 5. I could still do the work, but when I did the check, I'd find that neither solution would work out. Moving on. Number 4. In number 4, we again first begin by writing our two equations. 8 plus y equals 2y minus 3. And the second equation, 8 plus y equals negative 2y plus 3. And again, solve each one. I get 11 as the first solution. Now we'll do the same work over here. And we get a final answer here of negative 5/3. So again, before I can decide if both are my correct answer or if only one is the correct answer, I must do the check. For the sake of time, I'm going to skip question number 5. We did complete question number 5 in our notes in class, however, and I'm going to now use this space to do the check. When I'm doing the check, I must substitute into the original problem that had absolute value symbols in it. So that means absolute value of 8 plus, we'll do 11 first, equals 2 times 11 minus 3. So this will be the absolute value of 19 equals 22 minus 3. 22 minus 3 is 19. So we want to know, is this true? The absolute value of 19 equals 19 is true. It proves that the answer to this problem, one of the answers to this problem, rather, is 11. And let's check the other answer, the other solution. Again, substituting into the original equation, the absolute value of 8y equals 2y minus 3. This time substituting your negative 5/3. And surprise, surprise, we must know how to work with fractions. 8 plus negative 5/3 is 19/3, positive 19/3. So we have the absolute value of 19/3 equals 2 times negative 5/3 would be negative 10/3. And then we must subtract 3. Don't forget about that, subtracting 3. That gives us the absolute value of 19/3 is equal to negative 19/3. Negative 10/3 minus 3 is negative 19/3. So we must ask ourselves, is this true? Is the absolute value of 19/3 equal to negative 19/3? And it is not true. So that implies that the second solution of negative 5/3 is not a solution to this problem. That there is only one solution, and that one solution is positive 11. And we're finished. We will do this one last problem because it seems to cause some problems. It's so simple, people make it look a little harder than it is. Our normal instinct is to write two equations here. X plus 9 equals 0. And x plus 9 equals, well, there is no opposite of 0. So in this one instance, we would really only have one equation, and we would really only have one solution. And even if we did the check would turn out to be true. The absolute value of 0 is 0.